Every great idea starts with a what if. For us, that moment happened back in 2019. Driven by visionary researchers and engineers, we began a mission. Today, over 150 experts are building that future here at ePlane, one flight at a time. But dreaming is easy. Engineering an aircraft is not. When you're building something that flies, everything matters. A tiny aerodynamic detail, a slight structural deviation, a simple software bug, any one of them can compromise safety. And honestly, we didn't want the old aerospace cycle. Build, test, break, and repeat. That cycle is too slow, too expensive, and too risky. We needed a way to bring in certainty to the chaos of hardware R&D. That's when CADFEM and Ansys stepped in with a promise. What they gave us wasn't just software, it was a complete digital test environment. We now had the power to test thousands of scenarios without building a single prototype. We could break the aircraft safely and virtually. This partnership changed everything for us.
The biggest question was, how do we make something this compact to fly safely? With the Ansys, we could see the invisible. Instead of guessing how the design would behave, we could watch it unfold on our screen. That gave us more confidence to push our boundary of what this aircraft could do.
My world is structure, and structure is unforgiving. We need to know how this aircraft behave during the hard landings, turbulence, and even crash scenarios. And you don't get second chances in the real world. LS Jaina let us simulate hard landings, turbulence, even crash with utmost accuracy. What impressed me the most was not just only finding the failures, it was understanding why they happened. That's how we made the aircraft lighter, safer, and repeatable, without breaking the actual prototypes. After every modeling activity, we need to perform the LS Jaina for explicit analysis with CADFEM support to ensure the aircraft safety from crash simulation, with many iterations for material study and energy absorption.
Battery and safety go hand in hand, and high energy density batteries come with real risks. With Ansys, we mapped the entire electrothermal behavior, predicted hotspot, validated cooling strategies, and simulated failure chains long before assembly. Medini analyzed streamlined everything for us. HARA, FMEA, FTA, traceability. Instead of wrestling with the documents, we could focus on building a safer system. CADFEM and Medini allowed us to save about 40% of our time in these tasks.
People ask us, how do you iterate so fast? The answer is simple, HPC. What took days now takes hours. This speed let us explore more design, run more validation, and tighten the entire engineering loop. And high performance hardware support from CADFEM team, it's like giving our entire team a time machine. For example, if you take our E200X prototype 1, we have done nearly hundreds of iterations within 3 to 4 months.
Simulation didn't just give us analysis, it gave us acceleration. Suddenly, we were doing aerodynamic validation, crash analysis, rotor performance analysis, flight stability, even thermal dissipation, all digitally. Weeks of fabrication became hours of computation. Failures were learning, they were not expensive setbacks. It changed the way we planned, we engineered, and we built. And honestly, it changed the way we can dream.
At CADFEM, we see a future where AI-driven prediction, automated workflows, and multiphysics simulations converge to push engineering beyond traditional limits. As digital twins evolve into intelligent, self-learning systems, the line between the virtual and physical worlds disappears, enabling faster decisions, smarter products, and truly predictive operations. Collaboration like ours with ePlane reflect this shift, empowering engineers with speed, intelligence, and precision needed to build tomorrow's aircraft. Together, we are shaping a new era of mobility, which is cleaner, safer, faster, and engineered through simulation.
As we build India's most compact electric aircraft, everything starts with simulation. We're not just building an aircraft, we're building the future of urban flight.